Is time travel possible, or a mere figment of our overactive imaginations? This question has been at the heart of countless debates, scientific theories, and works of fiction. From the pages of H.G. Wells' The Time Machine to the silver screen adventures of Doctor Who and Marty McFly, the concept of time travel has captivated our collective consciousness for generations. It's the allure of the unknown, the tantalizing possibility of rewriting history or foreseeing the future that gives time travel its enduring appeal. Imagine, if you will, stepping into a machine, pressing a button and emerging in a different era. Would you choose to witness the dawn of civilization, or perhaps venture into the uncharted territories of the future? The concept of time travel isn't limited to the realm of fiction. It has been a recurring theme in scientific theories too. Einstein's theory of relativity, for instance, suggests that time is not a constant, but can be influenced by factors such as speed and gravity. This gave birth to the idea of wormholes and time dilation, concepts that, while complex, hint at the possibility of time travel. Yet despite these tantalizing hints, the reality of time travel remains elusive. The speed of light, the space-time continuum, the paradoxes that emerge when we consider changing the past, all these factors seem to conspire against us, turning time travel from a thrilling possibility into a formidable challenge. And then there's the question of evidence. If time travel were possible, wouldn't we have seen some evidence by now? A time traveler from the future popping up in our timeline, perhaps, or historical records that don't quite add up. Yet such evidence remains conspicuously absent. The idea of time travel throws up countless questions, each more intriguing than the last. It challenges our understanding of reality, pushing the boundaries of what we believe is possible. But how close are we really to turning this dream into a reality? As we delve deeper into the mysteries of time travel, perhaps we're closer than we think. To understand time travel, first, we need to understand time itself. Time, often referred to as the fourth dimension, is an elusive concept. It's not something we can touch or see, yet it governs our lives. Unlike the three spatial dimensions of length, width, and height that we can physically navigate, time is a dimension we move through involuntarily, always forward, never backward. Now, let's bring Albert Einstein into the conversation. His theory of relativity, which revolutionized our understanding of time and space, tells us that time and space are not separate entities, but rather intertwined into what we call space-time. Einstein painted a picture of space-time as a fabric, a cosmic tapestry, if you will, warped by the mass and energy within it. Picture a trampoline with a heavy ball in the center. The weight of the ball creates a dip, a curve, distorting the flat surface. That's how mass influences space-time. In this context, time is not constant either. It can dilate, slow down, in the presence of gravity or at high speeds. This is not some abstract concept, but a fact that has been experimentally verified. For instance, clocks on GPS satellites, moving fast and far from Earth's gravitational pull, run slightly faster than those on the ground. So if time can stretch and squeeze under certain conditions, could we not, in theory, manipulate it to our advantage? This is where the idea of time travel comes into play. The prospect of hopping into a machine, dialing a date, and being transported to a different era is an exhilarating one. It's a concept that has teased the human imagination for centuries, from H.G. Wells' The Time Machine to modern sci-fi blockbusters. However, the practicalities of such a feat are mind-boggling. They pose immense challenges, both in terms of our current understanding of physics and the technological capabilities required. It's no wonder that the idea of manipulating time to travel to different eras has sparked such fascination. But there are limitations to time travel that seem to make it an impossible feat. This statement, while disheartening for those of us who fantasize about voyages to the past or future, isn't without its basis in reality. Let's take a moment to consider these limitations. The first and perhaps most daunting is the speed of light barrier. According to Einstein's theory of relativity, nothing can travel faster than light. This implies that if we were to travel back in time, we'd need to move faster than light, which is currently deemed impossible. It's akin to trying to climb a mountain that becomes infinitely steep the higher you go. This barrier, a part of the very fabric of our universe, seems to be a firm no trespassing sign for would-be time travelers. Next, we encounter the paradoxes that arise when we contemplate time travel. The most famous among them is the grandfather paradox. It's a hypothetical situation where a time traveler goes back in time and kills their own grandfather before the conception of their parent. This, in turn, prevents the time traveler's existence. Yet, if they never existed, how could they have killed their grandfather? It's a loop that ties our brains in knots and highlights the logical problems inherent in the concept of time travel. Even if we were to ignore these paradoxes, there's still the issue of energy. Theoretical models of time machines often involve exotic forms of matter with negative energy, but such matter is not known to exist, and generating the necessary energy could require the resources of an entire star or more. So, if these limitations exist, how can we even begin to think about time travel as a possibility? It seems to be a daunting question, but remember, science is often about asking what if and exploring the boundaries of the possible. So while time travel remains an elusive concept, it continues to intrigue us, pushing us to seek answers in the vast, uncharted territories of the universe. Here's where the simulation theory comes in. Now, this is a concept that's been gaining traction in recent years. It's the idea that our entire universe, including us, might just be a sophisticated simulation, a grand program, if you will, run by an advanced civilization. Imagine a virtual reality that's so real you can't distinguish it from reality because it is your reality. How does this tie into time travel, you ask? Well, it's simple. If we are indeed living in a simulation, then the concept of time, as we understand it, could be nothing more than a programmed construct. A line of code that could be manipulated, paused, rewound, or fast-forwarded at will. This brings forth a fresh perspective on time travel. Let's consider this. What if time travel is not so much about moving physically through time, but rather about loading into different save points in our simulation? We might not be warping through the cosmos or tearing holes in the fabric of reality. Instead, we could simply be spawning into different parts of the program, carrying on as if nothing happened. Think of it like a video game. When you load from a previous save point, you're not physically moving your character back in time. You're simply reverting the game world to a previous state. If our universe is a simulation, then time travel could work in much the same way. This concept also offers a fresh perspective on the lack of physical evidence for time travel. If a program change is made in the simulation, then the data and information of that part of the simulation could be completely altered. There would be no trace, no markers left behind because the change is made within the code itself. Of course, this is all speculative. We don't have concrete proof that we're living in a simulation, let alone that we can time travel within it. But it's an intriguing perspective to consider. It challenges our understanding of reality and opens up new possibilities for what time travel could entail. Could we be loading into different save points in our simulation instead of physically moving through time? Ponder on that for a moment. The lack of physical evidence for time travel is a major stumbling block. This statement has echoed through the halls of scientific establishments for decades. However, when we view the concept of time travel through the lens of simulation theory, this lack of physical evidence takes on a new perspective. In a simulated reality, changes in the code could drastically alter the physical environment. If we imagine time travel as a program change, where the parameters of the simulation are tweaked to place an entity at a different point in time, then any physical evidence of this entity's previous existence in the original timeline could be wiped clean. In essence, the simulation adjusts itself, erases the previous data, and rewrites the new data seamlessly. This could mean that a time traveler's physical impact on their original timeline disappears the moment they embark on their temporal journey. But what if the simulation isn't perfect? What if certain anomalies or glitches occur when these program changes are made? These could potentially leave behind markers in physical space, subtle signs that something out of the ordinary has occurred. Imagine a scratch on a table that mysteriously disappears, or a tree that ages overnight. These could be signs of a simulation adjusting itself, erasing and rewriting data. In the context of time travel, they could be signs of a time traveler's presence. Of course, identifying these markers is no easy task. They would be incredibly subtle and could easily be mistaken for natural phenomena or even dismissed as mere coincidences. And even if we were to identify such markers, proving their connection to time travel would be an enormous challenge. So while the lack of physical evidence for time travel remains a hurdle, it's not an insurmountable one. as we continue to explore the fascinating possibilities of simulation theory, we may discover new ways to detect and interpret these potential markers of time travel. So, the absence of evidence might not necessarily be evidence of absence. And in the grand scheme of a simulated universe, who knows what subtle signs of time travel we may yet uncover? What if we could bend space-time to create shortcuts? This question has been a subject of fascination for physicists and science enthusiasts alike for decades. It's an intriguing concept that challenges our understanding of the universe and our place within it. The idea of bending space-time is like crumpling a sheet of paper. If you draw a straight line from one point to another, the distance seems quite long. But when you fold the paper, bringing those 2 points closer together, you create a shortcut. This is the essence of bending space-time, manipulating the very fabric of the universe to forge a quicker path. However, achieving this is no walk in the park. It's not like folding a piece of paper. We're talking about bending the very fabric of reality, a concept so mind-boggling that it's beyond our current human comprehension. It's like asking a caveman to understand quantum mechanics. We simply don't have the tools or the knowledge to even begin to understand how to do it. We are also limited by our current technological capabilities. Even if we understood how to bend space-time, do we have the technology to achieve it? Today's most advanced tech can't even come close to accomplishing such a feat. Our human limitations are not just physical or technological, they're also psychological. Can our minds handle the experience of travelling through a bent space-time? The very concept of time as we know it would be dramatically altered, challenging our perception of reality and our place within it. Yet the very fact that we're discussing this, that we're questioning our limitations and pondering the possibilities, shows our human spirit. It shows our innate desire to push boundaries, to explore the unknown, and to continually strive for progress. So, are these limitations merely a result of our current level of technological advancement, or are they insurmountable? This is a question that will continue to drive our curiosity and our scientific endeavours. After all, it's the impossible that pushes us to achieve the unimaginable. Perhaps we are not meant to travel through time, or perhaps we already are. In the grand tapestry of our existence, we have journeyed through the realms of science and philosophy, pondering the enigma of time travel. We've grappled with the limitations of light speed and space-time continuum, and yet the idea of time travel remains as tantalizing as ever. Reflecting on our discourse, one might argue that we are already voyagers of time, albeit on a small scale. We move forward, second by second, minute by minute, into the future. Each ticking of the clock, each turning of the earth propels us into the yet unknown, the unexplored frontier of tomorrow. In this sense, we are all time travelers journeying into the future at the steady pace of 1 second per second. The concept of simulation theory adds another layer to our understanding. What if our reality is not as solid as we perceive it to be? What if we are merely pieces of data loaded into different points of a grand cosmic program? Perhaps we don't travel through time, but rather we are loaded into different save points in our simulation. The absence of physical evidence may not necessarily debunk time travel. It could simply be that the information of that part of the simulation is altered when a program change is made, effectively erasing any trace of time travel from our reality. And then there's the idea of bending space-time to create shortcuts, a concept that has intrigued physicists for decades. If we remove the element of human limitations, could we not manipulate the fabric of reality to our advantage? The notion that we may be required to be in certain places at certain times for the simulation to run smoothly adds another tantalizing perspective. If we are loaded into the incorrect part of the code, is it mandatory for us to be moved? Or do we carry on where we are and figure out the data points from there? Whatever the case may be, the concept of time travel continues to intrigue us, offering endless possibilities for thought and exploration. So, what do you think about time travel? It's a fascinating subject, isn't it? And we've only just scratched the surface. We'd love to hear your thoughts on this topic. Do you think it's a possibility or just the stuff of science fiction? Perhaps you have a unique perspective on the simulation theory. Don't be shy. Share your thoughts in the comments section below. And remember, the exploration doesn't stop here. If you enjoyed this journey into the realm of time travel and simulation theory, make sure you subscribe to our channel and hit that notification bell. That way, you won't miss out on any of our upcoming content. We have plenty more thought-provoking topics to delve into, and we'd love for you to join us on this journey of discovery. Until next time, keep questioning, keep exploring, and who knows, maybe one day we'll find ourselves in a different time.